Hello, Assalamu alaikum. My name is Muhammad Haris Siddiqui, and today I'm to explain this. I have to explain this problem, which is called third maximum number. So basically, we have given we are given an array. We have to return the third distinct maximum number in this array. If the third maximum doesn't exist, return the maximum number. So first, we will see an example to explain properly. We are given an array which have values 3, 2, 1. The first maximum number in this array is 3, as you can see. The second maximum number in this array is 2. And the third distinct maximum number is 1, which is our output. I also see that the 1 is output because it's the third distinct maximum number. Now you can see in this array we have two numbers, 1 and 2. But the requirement which is given in the question is that you have to return the third maximum number, and there's only two numbers. So you can see that we can't return a third maximum number because we have only two numbers. So in this case, our third maximum number will be our second maximum number, which is in this case is 2. Now in third example, there are four numbers, but the problem is that we have duplicate numbers. 2, 2, 3, 1. The first maximum number is 3, the second maximum number is 2, and the first maximum number is 1. We have to delete that duplicate number and only take unique numbers. Consider unique numbers and take out the third maximum number in this array, which is 1. Constraints. So basically, the array length, num's length, should be greater than 1 and greater than equal than 1 and less than equal to 10 to power 4. So it means that the array which is given to us have the minimum length of greater than equal to 1 and maximum length of less than equal to 10 to power 4, and the number in the length in the array should have minimum size of minus 2 to power 31 and uh, maximum size of 2 to power 31 minus 1, greater than equal to 2 to power 35, less than equal to 2 to power 31 minus 1. So these are the constraints. We have properly understood the question behind it, what is required, what should be given. So I'm going to explain the logic behind what I did, what is the solution to it. The solution which I done it is very native approach. Um, so yes, so let's look at this example. There's an array. You can see. I can do this. Okay, two, two, three, 1. So this is the array which is given to us. What we have to do, we have to take the third maximum number in it. So first, uh, what we have to do is we have to take the unique numbers in this array. We can easily do this in Python by using the sorted built-in function. So it will take the unique numbers. It will give us then a uh, sorry, not sorted, set built-in function which gives us the unique number. So it will gives us 2, 3, 1. Then we have to take that set and convert it again to list because we can't iterate in a set. So we have to take the set and convert into list by simply using the built-in function list. Uh, so after that, what we have to do is we have to sort that function while using the built-in sorted function, which will gives us like 2, 3, and 1, 2, and 3. So this is the sorted function which will be using. Then what we have to return is a third maximum number. As you can see in this array, 3 what is the index of 3? If we have to return the reverse index, the index will be like this. If we have to return the return first maximum number, which is 3, we will do like this. We will put index in that array, and we will get that first maximum number. Likewise, minus 2 for 2, and minus 3 for 1. So this is the basic logic which I implemented. It is a native approach, and now we will take a look at how we will implement it in the code. So firstly, as I said, uh, I have to convert that list into set to use to take only unique numbers in it. So we'll see, um, list set nums. We convert that list into set, and then again set into list. So we will get unique numbers. After that, we take sorted take that list and convert that list into a sorted list. After that, I will use the logic behind it. If the length of nums is less than equal to 2, return -1. Return nums -1, else return nums -3. So if we can look at this logic, if length on nums is less than equal to 2, which in this example 2, you can see that we have to. I already explained it, that we have already two numbers in this array. So third maximum number will be second maximum number. So in this case, uh, -1 index is 2. So we have returned it 2. So in this, I have implemented this thing like that. And if we have simple 5 uh, uh, array of 5, array of 6, 7, we only return the third last third last maximum number, which will be like this. So we can see if it gives the right answer or not. Yes, it gives the right answer. Now we'll submit it. Yes, it is submitted right now. Now, what is the time complexity of this solution? First of all, if you can see this thing sorted, basically when we use the sorted function, it gives a time complexity of n log of n, both in best case and in worst case. So overall the time complexity of this solution will be n log of n, because of only using this thing. Elsewise, we have elsewise the all the other things will give us the time complexity of log of 1. So yes, I think time complexity will be in this solution will be n. You can see that n log of n. Mm, oh. So yes, time complexity will be this, and Otherwise, um, you can also do this solution by by using the heap concept, and by using trees. So yeah, that's the explanation of first example. Now we'll move to second example. Yes, now let's take a look at second example. In second example, which is called remove linked list elements. So what is given to us? Given the head of a linked list and an integer value, remove all the nodes of the linked list that has node value is equal to value. Return the new head. So what is given to us is given what is we have we are given a linked list, and in that linked list we are given number of nodes. So what we have to do is we have to check that node values. If that node values is equal to the value which is given to us, then we have to delete that node. Like you can see in this example, there's given an linked list. We have many, 3 4 5 6 5 6 7 nodes, and we have to delete only those nodes which have the value of 6. So in this case, this node and this node will be deleted, and the given output will be like this: 1 2 3 4 5, 7 nodes to 5 nodes. You can see that this is the linked list, and this is the value which we have to compare with these nodes value. And what will be given to us, like what will be output? We will give 5. We will give 1 2 3 4 5 nodes only. Likewise, in this we have we have given one value, and there's no nodes in that linked list, so we will return only we return none. And in this example, we are given all the nodes containing 7 value, and the value which is given to us is also 7. So we will return 0 nodes in that linked list. Constraints. So the node value should be greater than 1, and should greater than equal to 1, and should be less than equal to 50. Means the node values have the minimum value of greater than equal to 1, and the minimum value of a minimum value of greater than equal to 1, and maximum value of less than equal to 50. Or and the node and the size of the no size of the linked list would have minimum number of 0 nodes, like in this case, and the maximum number of nodes in that linked list will be 10 to power 4. So now we will look at the logic behind which I implemented in this problem. Firstly, let's consider we have 3 nodes. We have 3 nodes, like we are given 3 nodes, 1 2 3, and we are given a value 2. We have been given a value 2. So the value is 2. So we have to traverse through all the linked list to see that which node contains the value 2, and then we have to delete that node and gives the remaining nodes in the output. So we'll see that first we will create another node, for example this node. What we will do is we will point that node to that linked list. Now we will consider a variable, a pointer, which we take example in this case is temp. What we will do, we will assign that temp to this node which we created. Now what we will do is we will traverse that pointer in from the linked list for and check that which node has the value of 2. We will transfer that temp from to the linked list. If the value which if the value, for example, given was 1, so we will then check that temp next value. If temp next value is equal to 1, then what we will do is we will delete that node. But in this case the value of value is 2, so now we will traverse that temp variable through the linked list. We'll see that no, it doesn't contain 2 value. Now we'll again traverse to 2. Yes, the value is 2. Now what we'll do is we will what we'll do is we delete that connection of 1 and 2. We will what we'll do is we connect 1 to 3. So all the connection from all the connection of 1 from 2 is being deleted, and the only connection is now is 1 and 3. So the output will be like 1, 1 and 3. But we have another node which we created personally. We don't have to submit that node. What we have to do is our output is this. So what we will do is that we will delete that personal node. We will only submit this. So now we have understood the logic behind it, the solution. Now we will implement it in the code. First I will create a node which will be like a list node. Yes. Now I will point that uh, freshly created node to the given linked list. I will point to the first node of the given linked list. Like now, what will I do is I create a variable temp, which will point to the node, which will point to the node which I created. Now, what I do is I will traverse that temp variable through the linked list. While temp next is not equal to none. If it's equal to none, it will break out of the while loop. Now we will see that uh, if temp next value is equal to the given value, which is t in this case, what we'll do is we will we will break the connection. We will break the connection like in this case we will break the connection of from 1 from 2, and we will we will create a connection between 1 and 3. In this scenario 2 will be eliminated. So temp next should be assigned to temp next. Else we will only traverse through the remaining linked list. Remaining temp linked list. And then we will return the remaining linked list, like in this case 1 and 3. We will discard this node which we created firstly. So we will give in the end return node x. Return node x. So yeah, let's see if it's the right answer. Yes, it gives the right answer. You can see this in this array 6 is eliminated. 6 node is eliminated, and the rest node is rest linked list is given in the output. So we will submit that solution and see what's if it passes the other. Yes, it passes the other test cases also. Now the only thing is left is what is the time complexity of this given of this given solution. This thing we the time complexity of these lines will give us order of 1. But in this case, in while loop will traverse n number of times. So what we'll get is n. For now, we'll see that if and else is used. So we again see that order if will if loop will traverse n times. Likewise, this statement is traverse n times, and then likewise uh, um this statement is traverse through the linked list n times. So we'll see that n plus n plus n plus n means n plus n plus n, n plus n plus n plus n plus is equal to 4n. So the time complexity in this case will be like uh, order of will be order of n, big O of n, because we will we will eliminate the constant numbers and we will take only n. So in this case, it will be like this. So yes, this is the time complexity of this solution, as I prove it, and this is one of the solutions. There are many solutions to it. It can be uh, it can be done better, but this is my solution. Thank you for watching. Allah Hafiz.